Right. Okay, I'm gonna share my screen.
I guess there's another way to get consent. Just see how many people do the continue thing.
Hey, you guys see it?
Wow.
All right, so just a quick introduction to all of this. Oh, crap, how do I get that thing out of the way? Right, there we go. All right, so structures and airframe. So these are some of the main components that every rocket have. So this is a traditional dual deployment setup. It has a nose cone and a coupler that goes into, that is attached to the nose cone. It is removable from the foresection of the airframe. I just realized I can use this pen. Okay, can you guys see everything on the screen?
Yeah.
Okay, yep. So this would be the foresection, and this nose cone slides into that foresection right there. And the avionics bay is pretty much just a coupler that fits into the aft section, or the booster section is that. That's the foresection, that's the aft section. Yeah, so these are pretty much the main components. Every booster section would have a motor tube, so that you can fit the motor in it. We would also have centering rings to keep the motor centered. The line of thrust launched with the rocket, and you're also going to have a bunch of fins on the rocket. This is in order to keep your center of pressure behind the center of gravity. So this avionics bay is attached. Usually, it's attached to the core airframe. So you're going to have a bunch of screws in here that would be attaching this coupler avionics bay to the body tube. And the way the booster section or the aft section is attached to the avionics bay is via shear pins, which break off when the ejection charge fires. And the nose cone is also attached to the fore airframe using these shear pins. Okay, so yep, this is a traditional dual deploy setup. Which means there are two sets of chutes, usually the main and the drill. And we usually main in the fore section, not in the aft section, just because it's a little heavier and you want to keep the center of gravity further up. Although I have to mention that pretty often the aft section has a lot more space, so that's something to keep in mind. So on the body tube, so yep, these are all. So most rockets that you see here in the lab that we have are on the range of 3 inches and above. I think what's his name again? Scott? Is it Scott's Black Arrow? Is it? I think it's like a minimum diameter, about 2.6 inches. My rocket.
That sounds right. Yeah.
Yeah, mine would be a 4-inch diameter rocket. And I have it here with me. I can show you guys. Show it to you. So yeah, 4-inch diameter. If you really want to put a payload in it, whether it's a glider or a drone, you usually want to go 6 inches and above. And usually the larger diameter rockets, I would say 3 and above, they could be found using fiberglass. And some of the smaller diameter ones, they're most probably cardboard. Cardboard, yeah. Also, yeah, thought busters like metal rocket airframe parts. So no metal body tubes, no metal airframes. I think we have one rocket here in the lab that belongs to Tarun. Do you guys know Tarun? He was part of the very first FLI team here from Wichita State University, and his rocket had metal pins on it. I should ask him.
Yeah, Cloudbusters hated it.
Yeah, so this is, again, just some of our our rocket lab, our astronautics lab. So here are some common airframe materials. So phenolic tubing. Is there more? Yeah, here. So these are used for smaller sonic rockets. And they can be used for motor mounts as well. They are cheap. As you can see, they kind of look like cardboard. So they're a lot easier to cut, a lot easier to paint, and much more affordable compared to fiberglass or carbon fiber. They're also a very good base, which is what I'm planning to do with my level 3. So you can use this as a base, and you can lay up fiberglass or carbon fiber around it, as opposed to just buying a filament wounded carbon fiber tube. So that's also one of the advantages of it. So it can be used as an airframe on its own, or it can be used as a base material for your fiberglass or carbon fiber rockets. Oh, next we have blue tube. So are you familiar with this one? Because I'm not too familiar with it. If you want to explain about it.
It's basically tougher phenolic. It was used a few years ago. We've still got some in the lab. If you look around the materials, there's some lying around there.
Oh, I think I see some of them.
Yeah, it's just literally the blue phenolic. It's tougher, sturdier. I think they bill it as like 5 times tougher.
Mm-hmm.
It's pretty good overall. You might actually consider using that as your base.
Yeah.
It'll be a little bit heavier though than phenolic, but it is a lot sturdier.
Well, I'm trying to break the WSU altitude record, so yeah, maybe you might go with something lighter. Yeah. So again, just to reiterate, the pros: it's cheap, easy to cut, lightweight, it's sturdy. Some of the cons: zippering. So if some of you don't know what zippering is, so basically the airframe would have a shock cord passing through it. That's how we tether all of the different components together. So you would have a shock cord that goes through. And sometimes if your parachute gets deployed when your rocket is descending at a very high velocity, the shock cord can actually rip through the airframe. So you would get a rip right in here, and your shock cord would basically penetrate through the material. So that's what zippering is. That's what zippering is. There are some techniques that you can use to avoid that. Usually doesn't happen on airframes that are a lot stronger, such as fiberglass or carbon fiber. And they can burn. And like I said, they're heavier than phenolic.
Phenolic can too. Yeah, phenolic can burn too. It's all cardboard. Well, not technically, but.
And next is quantum tube. So again, they're definitely a lot stronger. They're used for subsonic rockets, but I think Scott's Black Arrow rocket, he used quantum tubing, and that rocket went supersonic, I believe. Yep, they're a lot cheaper than fiberglass, carbon fiber, a lot easier to cut as well. You don't have to wear like respirators like N95 masks and all those fancy stuff. You're not gonna get as much intense dust during the build process. So some of the cons is that it's
like strong PVC.
Yeah, right. So I was wondering when I first came to the Rocket Club, I was looking at some of the rockets that had quantum. And I was like, is that PVC pipe? Because it really like it. But yeah, it is like PVC pipe, but it's a lot stronger than it. Okay, we're on to fiberglass. So these are pretty much, assuming your rocket is not going ballistic or anything, these rockets pretty much last forever. They are extremely durable when it comes to drilling, and compared to phenolic or compared to cardboard, you're not going to get as bad of a blowout if you drill it through compared to some of the other cardboard rockets. And these materials can be used pretty much for the entire airframe. So you can use them for the motor tube, you can use them for the bulkheads, you can use them for, again, the aft and fore airframe, the nose. They can be used for everything. Like among other two, I pretty much use that for the entire airframe. And I have a time-lapse videos that I can show you guys later because I filmed the entire build. Wow. They are fairly expensive. So, for example, the airframe that I got for my level 2 rocket, I got it off Metcow, and I think the total price of everything came pretty close to about $400, and that's for a 4-inch diameter airframe, 4-inch diameter nose cone, 54 millimeter motor tube, and I got the fins cut out by Public Missiles. So, they are another company in which specify the dimensions of your fins, and you can just email them. They'll give you a rate, and they can get it shipped to you pretty quick. So almost all high-powered rockets are like 5 inches, or 5, 6, 7, 8, even 8 inches in diameter. Use fiberglass, at least use fiberglass as their structural component of the airframe. Then finally, we have carbon fiber. So again, if you want to lay up carbon fiber or fiberglass, the process is pretty much the same. These are available filament wound as well, and you can lay it up as well. They can be used for pretty much part of the airframe. Mancow has them. Your motor tube for airframe, aft airframe. They can be used for fins, nose cones, pretty much everything. Incredibly expensive. I haven't done too much carbon fiber rockets. We have one here in the Rocket Club. Was that part of a senior design project? Was it?
Yes,
Yeah.
it was.
You know how much that one cost?
Sorry?
You know how much that one ended up costing? Or at least just for
$10,000.
I don't think it was that much. I don't remember the exact number though. It was a while ago. That rocket was launched before anybody who's currently in the club ever joined the club. It kind of just stands there now.
Still our flagship rocket, or at least the main thing we kind of show off here in the astronautics lab. Yeah, incredibly.
Yeah, that's the current club record for altitude, 16,500 feet. So, just bring it over.
Yep. Again, yep, recommended for some of the most high-powered rockets that you can imagine, great by altitude rockets. Yeah, I'd say pretty much the material that my favorite airframe material, I would say it's fiberglass. It's relatively affordable, and assuming you're not gonna fly like Mach 2 or Mach 3, it should do just fine. So next we have couplers. So,
Fiberglass can do above Mach. It's pretty good for those.
yeah. Well, yeah, they can go above
Sorry.
Mach 2, but if you're gonna stay at that speed for a really long time, I think carbon fiber would be a better option.
Wait, carbon fiber is always a better option. It's just nobody has the moolah for it.
Go for it. Yep. So here we have we're gonna talk about couplers. So again, as the name is pretty self-explanatory, you join body segments together, bulkheads on each end. So can you see? Are you seeing the screen, or can you see what's on camera?
We're seeing couplers.
Okay. Well, yeah.
We can see like your screen on the sign if like that's what you're asking.
Oh, so you can see both of them at the same time. Right. Nice.
We only see the couplers slide.
Yep. So
Maybe
coupler.
it's different for everyone.
Pretty self-explanatory. They are used to join different rocket sections together, and each of them have a bulkhead on each end, like this one right here. This is the nose cone. That's a bulkhead, and it is attached on using the all-thread, the threaded rod that passes all the way through from the nose cone tip, the metal tip, all the way to the back of this bulkhead. And again, you want a bulkhead pretty much just to ensure that your parachute ejection bay or your parachute bay could be pressurized for deployment. And of course, they are used so that you can attach U-bolts over here. So you can attach a parachute on it. I don't have a U-bolt for mine. I put a little I-bolt on it, and I attached it to the thread. So yeah. So a rule of thumb, the total coupler length should be at least twice the body diameter. And we don't really have a photo up on here, but I can show it to you on my rocket. Can you, everyone see this? You guys see the camera?
Mm-hmm.
Yep. So again, the rule of thumb in the slide says that the coupler length should be twice the body diameter. So this coupler fits into the 4-body tube, and it's about 8 inches long. So the end's about right here. So again, the diameter is 4 inches across. You want the coupler to be 8 inches. So each end that goes into the airframe is 1 body diameter. So that's basically just. And for the nose cone, I believe it doesn't have to be as long. Half of it is fine. So for mine, 2 inches would be perfect. Go ahead and share that. So bulkheads.
I think the competitor 4 nose cone coupler is about 6 inches long in total.
Oh yeah.
Just for reference.
Yeah, the one on my nose cone is also slightly longer than 4 inches. So you don't have to go and that. It's not a must, but the minimum is that for the nose cone coupler, you want it to be at least half of your body diameter. All right, can everyone see the screen again?
Yeah.
Mm-hmm.
So here we have the bulkheads. So they are incredibly important, especially for your avionics bay, because the ejection shock is extremely corrosive and you don't want to damage any of your electronics. So this is a very important part that I don't think that many people actually know about. So you actually need 2 bulkheads on each end of your avionics. Thanks, Sai. You taught me this. So one bulkhead would fit inside your coupler, and another one would have a diameter that is slightly larger that would sit on top of your coupler. And this creates a much better seal to prevent any of the charge gases from coming through. So if I were to draw it, this would be your airframe. This would be your coupler. That would be a coupler. So your first bulkhead would be the diameter of your airframe, and the second one would fit inside the coupler, just like that. And you stack both of them up together. And again, you need holes for E-matches. You're gonna have wires that are gonna be passing through so that they can, so that you can attach the E-matches, and so that they can be inserted into the canister, which will hold all the black powder charges. Again, here nose cones, they are either made of plastic or fiber-wound fiberglass. Yeah, tongue twister there. If any of you are familiar with our Cert 1 kits, here it says it's recommended to drill holes in a plastic nose cone rather than using the pre-molded ring. The pre-molded ring, oh, there it is, right here. It's very narrow, and if you're gonna have a lot of tension on your shock cord, it might break apart. So it's recommended that you just drill a hole right here and pass your shock cord through. So here we have fiberglass nose cones. So this is the metal tip, and you're gonna have an all thread passing all the way through. This is your detachable coupler, and you're gonna be attaching them with screws to the nose cone. This end would fit inside the for airframe. And again, you're gonna have a bulkhead side or the aft section of that coupler. So this is the motor mount. This is what keeps your motor centered within the rocket. It doesn't need to be as long as the casing. So sometimes the casing can extend much further compared to the motor tube. This one out here is made of phenolic. I believe this one is used on our Argonia Cup rocket probe. Is that right, Sai?
Yep, that's correct.
I'm curious as to why you guys didn't proceed with fiberglass.
Yeah, we thought we knew better. And it did work for most of the launches. Then we got to like the last Airfest it was launched at, and you saw how that went.
I wasn't there. We didn't launch it. I think I went there.
Oh, you weren't?
And then decided not to launch it.
Oh, well, you can look at Hope right now. You can take a look at the fins and see what happened.
I'm looking at it right now.
It's explained right there. Phenolic is better for weight and CG, but you know, fiberglass will survive incidents like that.
Yep, as mentioned, it's.
If you design your rocket well and build it well, phenolic will work.
Right.
Sorry.
Right. So centering rings. So these are, see this little discs right here. Those are the centering rings. So that keeps the motor tube centered within your booster section. So if you're using a phenolic motor mount, you're going to use wooden rings. I believe this last one is a wooden centering ring. It looks like it's wooden.
We used a combination for Hope. You can actually see it in this one. We used sort of fiberglass sandwiched with wood, so we'd have something better for the aft section, for the center, for the motor retainer to bite into. So that was a bit of a special case there.
So yep, motor centering rings, they're pretty self-explanatory. So this, might be wondering, what's this big thing up here? So this is the retainer for the motor tube. So in order to prevent the rocket motor, because the rocket motor is attached by the casing is attached just by sliding it into the motor tube. And if you don't have any way of holding it in place, it will just slide back out. So this retainer fits on the aft section of your centering ring, and then you have another section that just screws on top, and it keeps the motor casing nice and snug. I actually made a really dumb mistake on my level 2 rocket that I can go through later on. So the fins, they're made out of wood or fiberglass. So if your fins are made out of wood, all wood have grains in it. They have a grain. So your rocket is going to be traveling this way. You want the grain to be perpendicular to the direction of travel, if I recall that right.
Mm-hmm.
So if you were to pretend this was a wood fin, you want the grains to be this way, like that. Again, these are fin tabs. This section right here. So if you don't have a minimum diameter rocket, that means if your rocket, if your motor tube is a lot smaller than your overall diameter, you would want to have fin tabs, just because 2 attachment points is a lot sturdier than 1. Oh yeah, here. If using wood fins, make sure the wood fin direction is perpendicular to the incoming. And sometimes these tabs, they're also called the tang. I think that's what public missiles use. But yeah. Again, these are the basic dimensions that is used to specify the geometry of your fins if you want to get them cut out by a third-party manufacturer. Oops. So My screen kind of stopped responding. Are you guys still seeing my screen?
Yes.
Mhm.
Okay, let me go on that again. Can you see the slides?
Oh yeah, there it goes.
Okay. Yeah, so the ballast, these are lead weights or metal blocks. They can be used to basically adjust where your center of gravity is. As you can see, there's like a hole in there. That's where you might want to pass through an offset or any other attachment points. And this one, I believe you can use 2 all threads to pass it through.
Mhm.
Yeah. And these are like, they're ridiculously heavy. Like, how heavy is this one? I have it in front of me, but I don't have a scale. So,
That's 10 pounds.
ooh, man.
That was supposed to go into a spade.
Yep. So that shot
That's
is,
all lead shot and candle wax.
so 2 of these would be heavier than my entire rocket with the motor loaded. That's how heavy it is. Yep. Again, yeah, don't use, if you're gonna use ballast or anything, ensure that your airframe can take the weight or any of the bending moments. So next up on the hard section, these are all threads, basically just really long rods that you can screw things onto, and they are primarily used as attachment points or a mounting point for your sled, for your avionics bay. So this one, as you can see there, like I mentioned earlier, there are 2 different bulkheads on each end. So this would be for the avionics bay. Your avionics bay right here. You can go ahead and mount all of your electronics. You can have 2 flight computers, 2 batteries. You can wire them up. I'm pretty sure I wired that wrong. But yeah, you get the idea. So rail buttons or launch buttons, they are used, so they're used to keep the rocket on the launch rail, and the launch rail is used to ensure that the rocket is traveling straight until it's fast enough so that the center of pressure moves further back. And these are,
Hey, that's a Callisto kit.
Actually, it's not. It's a Tethys.
Oh really?
Yeah, female Tethys. It's what I tried my Cert 2 on.
It looks the exact same.
It's beefier.
Oh, okay.
Otherwise, it is pretty much the same.
is that your rocket, Sai? Oh, it says Sai.
Yeah, that's my rocket. That's the best. That's the
I'm
yeah.
blind.
I label all of my components. That was the best picture I had of rail guides. So most of these components are mine. All of the other ones you're looking at, those are all my competitor kit.
So yeah, these ones are, what type of launch guides are these called? I don't know, these ones are called launch buttons because they look like
Those are rail guides.
Yeah, rail
Yeah.
guides.
And then I didn't have any pictures of launch lugs. I don't know if you want to add one in there.
launch lugs.
We
Well,
don't really use them anymore, though. Those are
We
the
used
long
to-
tube versions.
We used to have them on the Cert 1s.
Mm-hmm. Yep.
yeah, a launch lug is
You'll
just
see all this stuff in the lab.
Yeah. A launch lug is literally a tube that you put on the rail.
If some of you bought the Onyx kits, I think they come with a launch lug as well. So there are different size rail buttons. I think this is it like 1 inch and this is 1.5 inches? Is that right? I forgot what the
Yeah, it's something like that. Yeah. It doesn't really matter. They usually label the rails as 1010 or 1515. So you just gotta make sure you have the right ones. I know MTR uses 1515. I think Hope did too.
So these launch buttons, say this is your airframe. This end would be epoxied on the inside. It would be sticking out just like that. So you want to epoxy this in, and this could be your motor tube. So you really want to plan when you epoxy this section in, because if you don't epoxy them in and you have your booster section, motor tube in, and if you have an aft centering in as well, then there's no way you can get that on. So keep in mind. Then the launch would fit right here. Horrible drawing. So that would be launch button, the black one. And then in order to secure that, you would have the screw. And voila. Simple as that. And again, the launch button, you're going to need 2 launch buttons. So the aft button should technically be as far back as possible, but of course, you're going to have a lot of other components, such as the aft centering ring. So usually an inch from the base of the rocket. So, and for the forward button, I forgot what, there's a rule of thumb for it. Basically, you want all of the buttons to leave the rocket as late as possible. As late as possible, yeah. This ensures that the rocket is still guided with the rail guide as it accelerates through the rail guide. Geez, on words today. If you have them close to each other, so ideally you would want them to be really close, just so that they leave the rail last, and when the rocket is traveling as fast as possible. But that you would end up with binding issues with that. So I think the number is like, I forgot what that was. I wrote it down in my documentation for my level 2 rocket. I can share that with you guys later on. Yep, here are some suppliers: Wildman Rocketry, Mad Cow, this is where I got my airframe parts from. Rocketman for parachutes. Chris Rocket Supplies they sell a bunch of electronics as well. Serious Rocketry. I was looking for some closures for my rocket. Oh no, I just dropped it. Closures for my rocket because the Rocket Club didn't have a plug forward closure, which I needed to attach this eye bolt. I didn't get it from them. I got it from the guy, Mark, from the Science Education Center right here. So yeah, these are places where you can find all of the components that I was talking about. That's it. Anyone have any questions? Yep. So that's all for the very basic airframe and structures workshop.
Yeah, and we'll get to start building that in our lab hours, so get ready.
Yep.
It'll be fun. And we'll send out our lab hours tomorrow evening and an email update for you guys. So
I should
keep
be
an eye out for those.
again. So yeah.
Is there anything you guys want to do in lab hours that you're curious about learning about? Or do you want to get to building?
I could definitely use a little lesson on the different motor retainers.
Yep. We have a bunch of different motor retainers here in the lab. This one is from our antenna rocket. This is the flange motor retainer. Yeah, we've got a lot of them, and we can